Okay. Um, what we're talking about today is when you change the perimeter or the area of a shape, there's a scale factor, which is a ratio, and it also might change more than you think it does. So, first of all, let's talk about the ratio of sides. So, I could do this side, or I can do this side, and it should come out the same either way. So K's first, S is second, because that's the way the order they're in. So I could have 6 over 9, and if I divide both the top and the bottom by 3, I get 2/3. So let's do the same thing with the other sides. 12 over 18. Let's divide by 6. And you get 2/3, which makes sense because if they're similar, then they're proportional, and if they're proportional, all the sides should have the same ratio. Okay, so now let's talk about the perimeter of K and S. We're still doing a ratio. We're still putting K over S. So, what do the perimeter is 12 times 2 plus 6 times 2. So that's 24 plus 12 is 36. The perimeter of the second of S is going to be 18 times 2 plus 9 times 2. So 18 times 2 is 36. 9 times 2 is 18. 36, 46, 54. Okay, so let's put 36 over 54. And I know I can divide by 2, so I'm just going to divide by 2. I'm sure there's another number, but I don't know it off the top of my head, so that's going to be 18 and 27. And I can divide that by 3 or 9. So I have 6 over 9. Oh, which is going to look just like the same ratio as we had for the sides. Okay, now let's find the area of K is going to be 12 times 6, which is 72. And the area of S is going to be 18 times 9, which, searching for my calculator, I probably know that off the top of my head, 7162. Let's see if that's right. 162. Okay, so, I should have done it right here. 12 times 6, 72. 18 times 9, 162. So let's do the ratio of the areas. And what do you think it's going to simplify to? Two-thirds? Let's see if it's 2/3. But I don't know what goes into. I'm about to find out. Okay, I'm going to divide by 2 because I'm slow that way. Oh, 9 would have gone. Meh. All right, 36 over 81. I divide by 9. So I get 4 over 9. Okay, 4 over 9 can't be simplified. 4 over 9 should be related to what we got before. So look at this and compare it to 2/3. you hopefully noticed that this is, I'm going to change colors again, 4 over 9 is 2 squared over 3 squared. So basically it's the same ratio, it's just squared. So the ratio of the perimeters is equal or the same, and the ratio of the areas is squared. Not doubled, squared. Okay, so just remember that if we're doubling the area is going to get 4 times bigger, not 2 times bigger. So let's talk about scale factor. The scale factor is going to be the ratio like we found before of their sides. It's going from small to large. So we're going to go from 3 to 9, which is 1/3. It should be that the ratio of the perimeters is the same, but let's work it out. Because I have 3 times 1, 2, 3, 4, 5, 6 sides. So I have 3 times 6 over 9 times 6, which basically the 6's cancel out is what happens. 18 over 54, and then I'm just going to divide by 9 and get 3 over 9, which is 1/3. So 18 goes into 54. Okay, so it's the same. And we would expect the ratio of our areas to be what? And I'm not going to find the area of those hexagons. I can find the area of these. Example 7, but example 6, I'm not going to find the above them, although I could if I wanted to. Do I want to? I don't know. Okay, let's do the other one, see if I need to go back. All right. So the sides, remember we're going small to large. So I'm going to go 4 to 6, which is 2/3 again. Or I could do 8 to 12, even though it's not a side, it's the height. And it's also 2/3. So the perimeters are going to be also 2/3. I just can't remember if we found the perimeter. I can't remember if we did all the math to find the perimeter and the scale factor. I'm not sure what your teacher's going to do. I'm going to look it up. Okay, so the ratio of the perimeter should be the same. And now's the time to go find something to do, but come right back because I'm going to find 11.5. I'm going to look at the notes. I'm going to see if we actually did all that work. No, did not. Okay, so the ratio of the perimeter is going to be the same. And the ratio of the area is going to be 4 over 9. So same as the one we did above. So we can't find the areas of these. We would have 12 times, oh no, we wouldn't. We would have 4 times 8 and 12 times 6. And that would be 32 over 72. I could divide by 4. Does 4 go into 72? Yes. Nope, it does not. All right. 16 over 36. And I'm going to half it, 8 over 18. And I'm going to half it again, and I'm going to get 4 over 9, which is the same. Okay. So the ratio of the areas is squared. The ratio of the perimeters is the same. Okay, so now we have some word problems. We're just going to remember that we have similar polygons. So this would be small, and this would be large. So this is small, and we're looking for a large. All right, so we have 6 over 15 is the ratio, which simplifies to 2 over 5. Okay, so we're going to use 2 over 5 squared, which is going to be equal to 68 over the area of the large one. So we have to square it because the area ratio is squared. So if I have 4 over 25 equals 68 over x, I can cross multiply. And I'm going to have 4x equals 68 times 25, 1700. Divide both sides by 4. X equals 425. So 425 square centimeters. Okay, so the way I did this in my notes was I called this scale factor. And I called this area small, and I was looking for area of large. So I used the small and the large to separate them. Okay. Similar polygons. So here's the radius of the small one, the radius of the large one. The perimeter of the large one is 51, and we're looking for the perimeter of the small one. So scale factor, 8 over 12, which is equal to 2/3. Perimeter is the same, so 2/3 is equal to, remember the large one's on the bottom, like that. Cross multiply. 3p equals 102. Divide by 3. The perimeter of the small one equals 34 inches. Okay, so it's really just figuring out scale factor, perimeter or area, which one are you looking for, then proportion, and then solve. Okay, so let's follow those steps and see how it works. All right, now these are areas. So this is the area, the small, area of the large. And we're looking for the scale factor. So we're going to have to work backwards for this one. So we're going to do 81 over 196. And at some point, to get the scale factor, I'm going to have to square root. So, to get the scale factor. So the square root of 81 is 9. And the square root of 196, I think, is 14. So that would be the scale factor. If it had been the perimeters, it would have already been the scale factor. Okay, now we're going to do some changes where we're only changing one thing. So we have a rectangle. I'm going to draw my rectangle. It's 10 by 14. Okay, I'm going to draw a new rectangle. The length is doubled, but the width stays the same. So it's still 10, but now it's 28. So let's see what happens to the area. What do you think happened? Did it square? So the scale factor is, no, we can't really do scale factor. So let's do, because we're comparing the area. So let's do 14 times 10 is 140. So the area of the small one is 140. And the area of the large one's going to be 280. So to compare them, you could do a couple things. You could make a fraction, or you could just look at the numbers and think 140. Well, I know it's not squared. It looks to me like it's times 2. 280. So what happens is the area doubles. So if you change one side, it doubles. So we're going to do the same thing again with triangles. So here's my triangle. This is 8. And this is 12. I'm going to make it 3 times taller, but the same width. So now my height is going to be 36. So what do you think happened to the area? I'm thinking it doubled. No, just kidding. All right, so the area of the small one is going to be 8 times 12 divided by 2, which is 4 times 12, which is 48. And the area of the large one is going to be 8 times 36 over 2, which is going to be 4 times 36, which is 144. So I thought it was going to triple. So my guess, area triples. Let's see if it works. I'm going to take 48 and I'm going to multiply it times 3. 3 times 8 is 24. 14. So yes, it did. The area tripled. Because again, we just changed one side. And so the area is, that's not what I want to do. And so the area is changing by a doubling or a tripling. If I change both sides, then it becomes a square instead of like a double, which I guess makes sense.